All right, we're almost done. We found the center of the circle using, now we're going to use the distance formula with the center and one of the points you started with to find the radius. Actually, we don't have to use a distance formula. We can just use the standard form of a circle, which is a version of the distance formula to do this. We're going to find the radius. So since the center was 1, 5, and I'm just getting that off my graph. I didn't do that algebraically, but I know my graphs are accurate. So 1 comma 5. Since that's my center, you'll have a different center, of course. That's h comma k. That's what goes in here as h and k. And now I'm going to pick A, B, or C as x, y to plug in here. I can't use the center as my x and y because x and y is a point on the edge while h and k is the center point. So I'm going to use A. It would actually be easier to use B or C here probably. Um, no, actually, I think they're all equally difficult. As much as this is difficult, it's not really difficult at all, but I'm going to plug these in. So this will be a -2. H was 1. Y was 9. And K is 5. So I'm going to plug in -2 minus 1. I'm going to square that. And I'm going to go plus 9 minus 5 squared. And that'll equal r squared. So 9 minus 2 is -3. Squared is 9. 9 minus 5 is 4. Squared is 16. And, ooh, that's nice. It comes out to 25, which is r squared. So that means r equals 5. So the radius of our circle is 5. Now write the equation of the circle using the radius you found and the circumcenter as the center. Check that each point substituted in the equation as a xy validates your result. So your last step here, number 7, is to write your equation. My equation is x minus 1, because that's h, plus y minus 5 squared equals r squared, which is 25. And I would check that by using B and C to verify. Okay, and we're almost done. So let me go to the next page now. Now perform the following 2 graphical checks. I'd have you do both at once, but I believe Green Globs only supports 6 equations at a time in the equation graphing program. Using the Green Globs equation grapher, input all 3 equations for the sides again. So those are the ones that give you a triangle. Okay, the first triangle. And then input your equation for the circle. If performed correctly, your circle should cross through each corner of the triangle. So your circle should hit all 3 points, which is a no-brainer because these were the 3 points we started with. So the circle better hit them because they are supposed to be on the edge of that circle. The other graphical check, so you want to include that, copy paste that into your Word document. The other graphical check I want you to do is using the equation grapher, input 3 equations you found for the perpendicular bisectors. So the perpendicular bisectors of these guys, so this won't actually be here, this triangle, but the perpendicular bisectors will. And the circle, and graph them along with the equation of the circle you found. If you did this correctly, the center of the circle should be in the intersection of the equations. So the center of this circle here should be in the center of that, in the intersection of the equations. So um, it's kind of a redundant check. Ideally, though, if you can put 7b and 7c on one graph, that's beautiful because then you have the triangle, the perpendicular bisectors, and the circle all in one. And that's actually the goal. Okay, on a new piece of graph paper, graph the triangle, the midpoints, in the center. Connect the midpoints to and through the center in both directions for the perpendicular bisectors. And when you come to class, I'll loan you a compass to complete the circle whose equation you found. Um, you don't actually have to do this if you're doing this uh, in one of my distance classes, but if you're on campus, you need to do this. That's the last step. It's self-explanatory, and that is the whole lab. Hope this was helpful. Bye-bye.